So in the last part, we saw what is Reynolds number. We saw it as to be a marker for the relative importance of the fluid kinetic energy to the shear energy, and I also mentioned that from empirical observations, it is known that a Reynolds number for pipe flow which is less than 2300 leads to a laminar flow, and anything more than that generally leads to a transitional or turbulent flow. Now, I also mentioned that if the Reynolds number is more than 1, it means the flow is dominated by kinetic energy, while it is much less than 1, it is dominated by shear forces or viscous effects. Now, why is this number 2300? Like, what is the significance of 2300? We don't know the answer to that question. We don't know why it's 2300 and why not 2400 or why not 4200. It's generally in the range of 22 to 2400, something like that. But the more important question is, what does it mean to have a Reynolds number that is larger than 1, and what does it mean to have a Reynolds number that is smaller than 1? Now think about the Reynolds number itself. If you have a flow with a velocity v, based on the parameters, you can compute the Reynolds number to be rho Vd over mu. Now what does this mean? The fluid packets, that is each packet of fluid, they have some kinetic energy, and it is like if you have a lot of kinetic energy, the fluid has to find a way to transport it through the flow. That's one thing. The other is the effect of shear force is to take away energy from the flow through viscous interactions, through non-conservative interactions, through interactions that turn kinetic energy into heat, and that heat eventually leaves the system. So if you are thinking about this as a system as a whole, don't look at the microscopic picture, just think big picture. I input a certain amount of kinetic energy, okay? If the fluid has too much energy, that's when it starts transporting the energy in transverse directions and leads to turbulence. If the fluid has less amount of kinetic energy, the input kinetic energy travels in nearly uniform pathways or more laminar like flow. That is, if the amount of kinetic energy is not too high, then it leads to a situation where the flow takes place layer by layer, where there is orderly motion and the fluid propagates as a laminar flow. And that is the situation that is covered generally by Reynolds numbers that are less than 1. When you have Reynolds numbers that are more than 1, that doesn't necessarily mean that the fluid is not able to transport the momentum. The fluid, based on the flow velocity and its viscosity, there is a certain rate at which energy is dissipated by fluid shear. The rate at which energy is dissipated by fluid shear, and this rate, if it is good enough or if it is enough to remove sufficient amount of excess kinetic energy from the flow, that is by dissipation, let's say that you dump in a certain amount of energy into the flow. If that energy is removed from the flow quickly enough, then the flow stabilizes to an energy value that can sustain a laminar flow. You remove energy at a sufficiently fast rate, and what usually happens is the rate at which you can dissipate energy reaches a plateau quite often, reaches a maximum value quite often. The maximum energy removal rate or power dissipation rate, reaches a certain value. Beyond that value, if you input more energy into the flow, that goes into creating turbulence. So it just turns out that 2300 is about the threshold for the amount of kinetic energy that the fluid can transmit through itself while balancing viscous dissipation. Any more energy that you put, any more higher Reynolds number that we create, leads to a situation where the fluid cannot handle all the energy just by laminar transport. It needs additional energy transport mechanisms, and that's where turbulence comes in. Okay, so you just have to remember this number, and this can change from situation to situation. Like for example, when we see external flows in module 8, the transitional Reynolds number is a different number. It's some other number. So this is not universal, but what is universal is there is always a critical Reynolds number below which the flow is laminar, and there is always a transitional range of Reynolds numbers, and above a certain Reynolds number the fluid simply cannot sustain laminar flow. It transitions into a more turbulent flow mechanism. So that is the key idea here. So this taxonomy is usually valid. Reynolds number is a good indicator whether a given fluid is going to undergo turbulent flow, transitional flow, or laminar flow. This is generally a good indicator, but it's not always set in stone about the number 2300. Okay.